Hi everyone, my name is Sam Connerly, and today we're going to be looking at the Physics2212Lab1 charge tapes. So first we're going to talk a little bit about the lab. The purpose of this lab is to learn about the transfer of electrons through different surfaces, and we're going to be doing this through using tape. Some details about the lab. First, we're going to make an assumption. This assumption is each tape has equal and equally distributed charges to start with. We're going to use a couple formulas. We're going to use Newton's second law and Coulomb's law, which you can see below, and we're going to use constant charge of electrons for our calculations. The two formulas, of course, Newton's second law, force equals mass times acceleration. Coulomb's law, force equals a constant K times Q1, Q2 over R squared. So let's go over the procedures for the lab. So the first thing we're going to do is we're going to create U-tape by attaching one piece to another piece of tape, then removing it. This is to cause a transfer of electrons. Then we're going to suspend a piece of U-tape using blocks, and then we're going to take a second piece of U-tape and put it underneath the suspended U-tape. And for the lab, we're going to be making some observations on the interactions between the two pieces of tape. For this lab in particular, we are not going to be doing it physically, but instead we're going to be using VPython, and we're going to be doing the calculations for the experiment that we would normally do by hand as well in VPython, with some visuals that we will go over once we get to those. So to start with, we need to have a couple of initial numbers and results that we need to put into our calculations on VPython. So first, we're going to assume that the mass of the tape is 2 times 10 to the negative fourth. We're going to look at the electric charge on the tape, which we're going to calculate as to 1.2 times 10 to the negative 8th coulombs. We're also going to find out that the tape is deficient with 7.5 times e to the 10th electrons. And the distance between the tape is going to be 0.025 meters. We're going to find that the two pieces of U-tape repel each other. So for the coding, we're going to first put in all of our variables that we already have. The first one is 1 over 4 pi, the mass of the tape, the length of the tape, and the width of the tape. We're also going to factor in for gravity and get the distance between the tape. This is going to allow us to get the electric field of the tape, and those are the calculations that we do in the next part. Then we can see that once we plug all that in and run the program, it gets our electric field of tape as 1.2 times 10 to the negative 8, which is what we mentioned in the previous slide. So for the second part of the code, we're actually going to look at the effects on the tape over each other. So kind of similar setup to what we did previously, is that we're going to set up all of our variables first that we know. Then we're going to start looking at the magnitude of the electric force total. We're also going to look at things such as the number of deficient electrons. This is kind of coming from the charge calculations that we get, how they interact. We can actually get a number for how many electrons were lost on that initial setup. We can get a good idea also as well about the number of atoms once we get that electron number. And then we're able to get a ratio, and that kind of helps us understand the initial interaction when we're setting up the tape at the beginning of the experiment. And then as you can look over to the right, we can see those two gray dots represent our tape. The green arrow is the force of gravity on top of the suspended piece of tape, and the red arrow is the force of the second piece of tape on the first piece of tape. And we can see some of those numbers that we talked about calculating in that box. So when we're talking about possible sources of error for our experiment, first we want to look at the reality. This is if we were to be doing it in person. Touching the tape with our hands during setup, which we'll go over in a second, could cause errors. Potential human error in keeping consistency between the pieces of tape. And then inaccurate tape sizes for calculation. This could just be human error in actually cutting and measuring the tape. And in calculations, by putting in some of the numbers and rounding ahead of time, it could lead to some inaccurate numbers. And if we plug in inaccurate measurements into the code, it won't get fixed into the program, it won't cause errors. Some things we want to discuss: what if the electrons change signs? And the calculations, the positive charge tape would have a flipped electric field. But in our observations, we realized that two pieces of tape would still repel each other because they would still have the same charge, which would cause them to repel. And then kind of like we mentioned about handling the tape, the charge on the tape could accidentally also be transferred to fingers and other objects in transference, which would cause some discrepancies in the experiment. Thank you. There will be a link to the code in the description, and hope you enjoyed.